I've just started the recording. Okay. Okay, again. Okay, let's say for this example, before I continue to the continuity, I would like to share with you again how to uh, find the limit. Let's say this question is from exercise, one of the exercise. Let's say we have these two functions. First, the limit when x approach infinity, and then the second one when x approach negative, negative, negative 8. Oh, so in this case, uh, what we should do is we just based on the properties of limit, we just substitute the value of the x. We just substitute if x equal infinity in the first equation, and then the second one x equal negative infinity in the equation. So from the first equation, from the first function, so if from the first function, we get infinity divided by infinity. Okay. Then for the second function, we have here is negative 8 squared. That is a 64. 8 times negative 8 times negative 8 is positive 64, minus 64 divided by negative 8 plus 8 is 0. Okay, this part is actually is 0 divided by 0 divided by 0. This part. 0 divided by 0. Okay. So in this case, we have two form here, two unique case here. The first one is infinity divided by infinity. The second one is 0 divided by 0. Okay, if you refer to my note, okay, for the first case, infinity divided by infinity, what we should do is we must just select go back to the function, to the original function. Okay, for the first function, for the what we call it in this you can refer to the okay, please refer to page in mine in part A, part A, page 9. Please refer to note for limit. There is a form of 0 divided by 0 and infinity divided by infinity. So for the infinity divided by infinity, what we must we just uh, we just select the term of the for the numerator and denominator. We just choose the term with the highest degree in numerator and denominator, the higher degree of x. So for the first, for the numerator, okay, this one, for this numerator, uh, the highest term is, the highest degree of x is 7x to the power of 3. And then for the denominator, the highest term, the higher degree of x is 2x to the power of 5. So based on this concept, we can rewrite the limit as the limit 7x to the power of 3 divided by 2x to the power of 5 when x approach infinity. We just choose the highest degree of x both in numerator and denominator. Okay, this the first we can we arrange the limit of the function as a limit for the function 7x to the power of 3 divided by 2x to the power of 5 when x approach infinity times, okay, this part, uh 0 divided by 0. Okay, 0 divided by 0 is refer to page 9. Okay, what we can do based on this concept, there is a tip here. We just, I hope you still remember, we have a squared minus b squared equal to a plus b divided by a minus b. We need to, the function must be, we need to transform the function into this form. Okay, so if from the numerator, okay, we have negative 2 negative, sorry, x squared minus 64. Okay, this can be rewrite as x squared minus 8 squared, because 8 to the power of 2 is x times x, 8 times 8 is 64. So this form can be, we can expand this equation. X squared minus 8 squared equal to 8 plus, sorry, a plus 8, a plus, sorry, not e, x. This equal to x plus 8 times x minus 8. Okay, so I can this function, this limit, this equation can be rewrite, can be arranged, can be rewrite as this. The function now become to okay, this is okay, this one equal to, oh sorry, x plus 8 times x minus 8 divided by the denominator is still the same, x plus 8. That's not change. We just adjust the, we just expand the numerator. So now, okay, sorry, this one is still we need to write the limit. The limit of this function is it is a limit of the function when x approach, negative 8. Okay, this one times. Now we can uh, solve the equation. First, we need to, the first step is we try to simplify the equation. Try to simplify the equation. For the first part, for the first function is we can slash this number 8 to the power of 3 and 8 to the power of 2. Right? Okay, please wait for a few minutes. Yeah, I have a call. Okay. Okay. Then okay. The next is about the, okay. We need to simplify the limit. Uh, okay. From the first part, okay. This we can slash 7/8 to the power of 3 divide by 2x to the power of 5. Now this part is equal to in other words, this equal to limit when x approach infinity, 7 divided by 2x to the power of 2 times. Okay. The second part is we can remove x plus 8 because they are same component from the numerator and denominator. We can slash, so this become limit when x approach negative infinity for x minus 8. Okay, now we can proceed this calculation. We can find the limit now. Okay, so for again back to the or and then we can apply the property of limit. Okay, what is the property of limit? Based on the property of limit, we just substitute x into the equation. So this is equal to 7 divided by 2 times 2 times infinity to the power of 2 times the second one is x, okay, x approach negative 8, negative 8, negative 8. So this one is negative 8 plus 8. Okay, so in this case, okay, 7 7 divided by 2 times infinity. The answer is 7 times infinity. Sorry, 7 divided by infinity. 7 divided by infinity. 7 divided by infinity times negative 60. Okay, this part is 0. One number divided by the one large number. The answer is 0. 7 is a constant number. When constant number is divided by the one big number, one large number, for example, infinity refer to the big number. The answer is 0, and then 0 times negative 16. The answer is 0. Okay, that's how to find the limit. What is a limit all about? Okay, this question is from exercise topic 5, limit and continuity. Okay, that's about the limit. Okay, from this concept, we need to apply the concept. This concept is very important in the context of continuity. Now, okay, I would like to explain about what is continuity. Again, continuity is keselancaran. When we talking about continuity, in other words, we can say in a simple word, we can say that there is no break, no hole in the graph. No break or no hole in the in a graph. Maybe I can write here, no tidak terputus. No break, no hole, or tidak terputus. In bahasa namanya gajah tersebut tidak terputus. Gajah tersebut tidak terputus. In other words, we can say there is no break. When or by definition, if you refer to the textbook, continuity in mathematics means that the function behaves smoothly. In other words, the function is smooth, behaves smoothly without any break, jump, or hole in its graph. There is no break, no hole, no jump in the graph. Or in other words, when we draw the graph, if a function is continuous, if we draw the graph, we can draw the graph without lifting your pen, without lifting our pen. You can draw one graph without lifting your pen from the paper. Kita boleh lukis tanpa kita angkat pen. Itu maksudnya tidak. Itu maksudnya tidak terputus. Okay, for example, let's say I choose one or two. Let's say for example, so before this we learned about linear, quadratic, and so on. We learned about quadratic linear function, quadratic function, and log and exponent. Okay, for example, let's say I have this function y equal to x squared. We know this is a quadratic function. Let's say y equal to x squared. Y equal to x to the power of 2, x kuasa 2. Okay, how to draw this graph? We know that when we draw this graph, let's say this is x, this y, we can draw this graph without lifting. Without lifting pen from the paper. Let's say when I draw this graph, okay, I can draw this graph like this. Okay, there is no break or no hole in the graph. That's why I can say the graph is continuous. The graph is continuous. Okay. And then let's say I have for example I just want to show you how to compare the continuous and non-continuous, continuous and non-continuous, selanjar dan tidak selanjar. Let's say there is a break. Let's say there is a break in the in the graph. Let's say for example, let's say I have this just for example. Let's say the graph is like this. Let's see how to. Yeah. Let's say I have this graph. Let's say based on this graph, let's say there is a hole. Okay, I just cut this point. I just put this point as a white circle here. White circle here. When I draw this graph, I need to leave my pen at this point. Jari terputus. When I cannot draw continuously. But when I draw this graph at this point, at this hole, at the white hole point, I need to leave my pen because the graph is non-continuous. That's why we call it, and this at this point, the graph is not continuous. In other words, what is selanjar? What is continuous? Continuous refers to the situation where we can draw a graph without lifting our pen from the paper. There is no break, there is no hole in the graph. Okay, that's continuous. Okay, suppose if you refer to the page, okay, let's say I have this this function. This function is y equal to x. Okay, this function is y equal x. I can draw this graph continuously. Not there because there are no break in the graph. But okay, let's say we refer to the g, the function of g. Okay, there's a function of g. Okay, g is discontinuous or non-continuous. G adalah tidak selanjar at x equal 1. Okay, when I draw this graph at point x point 1, I need to jump. There is a jump. When I draw the graph, when we draw the graph at this point, this line cannot we need to leave our pen, or we cannot draw the line continuously at point 1, x equal 1. And then when we want to continue, we need to jump that point, because this gx say that if we refer to this function of gx, the gx say that this function can be how to read this function, how to define this function. The function say that gx equal x if x does not equal 1, but gx equal 2 if x equal 1. When x equal 1, gx equal 2. That's why we have a black hole here. When x equal 1, y equal 2. When x equal 1, y does not equal 1. So that y equal 2. That's why in this case there is a jump, there is a hole, there is a break. The graph of gx is discontinuous at point x equal 1. Okay, that is the continuous. Okay, if you have any question, you can ask me anytime during the class. Okay, okay, that's about continuity, keselanjaran. Keselanjaran bermaksud graf tersebut tidak selanjar. Graf tidak continue masuk graf tidak terputus. There is no break, no hole, no jump in a graph. Okay, so the question is how to determine whether the graph is continuous or discontinuous at point E, at point x equal A. Okay, the first, if you refer to this example, based on the theory, we need to draw the graph. We can draw a graph, we can draw a linear function, quadratic function, log exponent easily, but certain graph, but for the graph like There is no easy actually when we want to draw the complex graph. There is a combination of linear and quadratic and so on, and then it's very difficult to draw the graph. That's why they are we can determine the we can decide, we can check whether the function is continuous or not by following these three conditions. The three condition here must be fulfilled in order uh, there is a three condition here that must be fulfilled for a graph at certain point. uh, Based on this condition, we can conclude later whether the graph is the function is continuous or at continuous at point A. Okay, normally when we're talking about continuous, we refer to the very specific point, at point x equal 1, x equal 2, and so forth. We just not check the continuous for the whole graph. Our focus mainly our focus is to we need to choose one value of x. It doesn't matter whether it's negative or positive. At that point, when x equal a, we can check, we can determine whether the function is discontinuous or not by following these three conditions. These three conditions must be met in order for the graph to be continuous. Okay, the first one, this one, fa exists at point A. In other words, the function is defined at that point. The function is defined at point x equal a. There is when x equal a, we can find value of y. In other words, we can draw the black hole. I hope you still remember when I explained about the white hole and black hole, or black circle and white circle. Black circle means the function is defined at that point. We can find the value of y when x equals a, for example. Okay, that's the first condition. The second one is the limit of the function when x approach a must be exist. The limit of the function exists at that point. Okay, the first one, the y is defined. The function is defined. The limit of the function exists at that point, and the value of the limit. Okay, that's the second one. The third one, the value of the limit, the value of the function, the first condition equal its limit at that point. The value of y equal to the limit of the function at point x equal a. Okay, these three conditions must be fulfilled in order to be continuous for particular graph. Okay, if you refer to this 1, 2, 3, and 4 graph, okay, that's example of this continuous. Okay, for the first one, this function is not continuous because the function is undefined, does not exist. There is no black hole. And then the limit also does not exist. The limit meaning that when x approach a, whether from the left or from the right, the value of y has no limit. The value of y is keep increasing. It's increasing when x push a. In this case, the function cannot be defined at point a. The limit does not exist, so we can conclude that at this point the function is discontinuous. There's a gap. There's a hole in the function. Okay, for the second one, there is also example of fx discontinuous. Okay, in other words, we can say that the value of the y, the function is defined. The function is defined at this point. That's why because we have a black circle here. The function is defined, and the limit is exists. The limit of the function is exists in this case. The limit of the function is, but the limit of the function, the value of the limit does not equal the value of y. That's why, as you can see here, there are 2 points. The first one is a white point. The second one is the is a, we can say they have a black point. The value of y exists at that point, but the value of limit exists at a white circle point. So in this case, the value of the function does not equal the limit. So we can also conclude here fx discontinuous at this point again. Okay, for the point number 3, okay, that is very clear. That's very clear. There's no, that's not continuous, because although the function has the value of the y exists, because they have a black dot here, but the limit does not exist. The right hand limit does not equal the left hand limit. This one. That's why the limit does not exist. So again, fx discontinuous at this point. Okay, okay. The next example is, okay, we have this graph, but in this graph there are only one white circle here. In this case, since there is at point A, now I'm talking at point A, not other point. At point A, as you can see here, the value of y does not exist. The function is undefined. The function is undefined at point x equal a, because there are no black hole here. We only have one white hole here. So we can conclude here that the function is undefined at this point. The limit of the function exists because the right hand limit have the same direction to the left hand limit. So the limit exists, right hand limit equal to the left hand limit, but since the fa, the function, that the value of y is undefined at this point, we need to conclude that fx is discontinuous at point x equal a. Okay, that's based on the graph, how to determine the continuous of the function. Okay. Okay, that's for your information. The polynomial function. There is a linear, polynomial, linear, quadratic, log, and exponent. All this function is known as a polynomial function. Normally, a polynomial function is a discontinuous, is continuous at every point, unless there are another information show that the function is discontinuous. In normal case, all the linear, quadratic, log, and exponent are continuous. Are continuous at every point. You can check later whether this statement is true or not. A rational function. In other words, rational function refer to, we have two functions. We have the numerator divided by the denominator. That's why we have the rational function. The rational function is discontinuous at point where the denominator is 0 and is continuous otherwise. The value of the denominator of rational function is very important. They will decide whether the function is continuous or not at that point. Okay, that's the basic concept of limit. Can share with you here today. Okay, the next one is how to find limit. Okay, so far, sorry, how to find continuity, how to determine continuity. So far, we need to find continuity by sketch the graph. We need to sketch the graph first. So, but in other case, we can find the continuity without sketch any graph, without draw any graph, without graph. In other words, without graph. Okay, just follow these three conditions. Just follow these three conditions. The first one, the value of the function is exists. The value of the function is defined. The limit is exists, and the value of the function equal to the value of the limit. Okay, that's the condition. The three conditions must be met for any function. to be continuous at the particular at a certain level of x. Okay, for example, let's say for example, okay, please refer to page 3. To page 3. Okay, I will explain this example. Okay, let's say I have this function. Okay, I have this quadratic function fx equal to four x squared plus 3x, 4x squared plus 3x, uh, 4x squared plus 3x plus 2. And I would like to determine whether the function is continuous or not at point x equal 5. At point x equal 5. 4x squared plus 3x plus 2. Okay. Determine whether this function is continuous or not at x when x equal 5. So for this, how to answer this question? You must follow the 3 rule here. The first one, you need to find f5. But we need to check whether f5 is defined. What is f5? What is the f5 refer to the what is y when x equal 5. In other words, we just substitute substitute x in the equation. 4 times 5 squared plus 3 times 5 plus 2. Okay, the answer is 11117. So the first rule is fulfilled. Okay, the function is the value of y is defined. We can find the value of y is defined at point x equal 8. So there is a black hole, black circle here, black dot here, black dot or black circle when x at this point. When x equal 5, y equal 117. There is a point for this point is a coordinate point for the function. Okay, that's rule number 1. The rule number 2, we need to find the limit of the fx when x approach when x approach 5, because x equal 5 is the number given in the equation. We need to determine the whether the function is continuous or not at this point. Okay, so how to find the limit? Okay, for this case, we must find we need to check whether the limit exists or not when x equals 5. So how to check? First, we need to find the right hand limit and left hand limit. Okay, what is right hand limit? Hat sebelah kanan. The limit when x approach 5 from the left. So from the right. From the right. For function 4x squared plus 3x plus 3x plus 2 plus 3x 4x squared plus 3x plus 2 when x approach 5 from the left. So based on the limit property of limit, we can apply the concept of property of limit without using any graph. We just based on the theory, we just substitute x equal 5 in the equation. Then we determine whether there is a number or not. 4 times 5 squared, 4 times 5 squared plus 3 over 5 plus 2. The answer is 117. Okay, the right hand limit is exists for this function. Next, we need to check the left hand limit when x equals 5 from the left. When x equals 5 from the left. For function 4x squared plus 3x plus 12. Okay, based on the property of limit, well, we can apply, we can substitute x equal 5 in the equation. 4 times 5 squared plus 3 times 5 plus 2. The answer is 117. Okay. For this case, okay, for this case, okay, the right hand limit equal to left hand limit. Right hand limit x equal 5 for the left, fx for the function f I write in general, equal to the left hand limit x to the power f to when x approach 5 from the left for function fx. And the answer is the same. The answer is negative, positive 5. Sorry, the answer is 117, not positive 5. 117. Because the left hand limit is 117. The right hand limit is 117, and the left hand limit is also 117. So the answer is the right hand limit equal to the left hand limit. In other words, the limit of fx is exists. The limit when x approach 5 of fx, the value fx exists. You can say the limit is exists. Here, the limit is exists for this for the function. So that's rule number 2. Okay, that's rule A, B. So if we refer to A, the limit of the function the fx is defined when x equals 5. Okay. The second one, the limit when x approach fx exists. The limit is exists. So we can move to the condition number 3. There are 3 conditions here. Condition number 3 is we need to check whether f5 equal to limit of fx when x approach 5, for example, when x approach 5. So in this case, as you can see here, the limit, the value of y and the limit is equal. This is equal 117. So this when x equal 5, this function fulfill all the 3 conditions. In other words, the function pass all the requirement. So we can conclude that since the function is exists, the limit is also since the y is the effect is defined, the limit is exists, and then the value is defined, the limit exists, the value of y is equal to the limit when x equal 5. So we can conclude that the function is continuous at point x equal 5. Fx, we can conclude fs is continuous at x equal 5. If you refer to my notes, okay, if you refer for the example, we can conclude here that fx is continuous at point x equal 5, because at this point the value of y, the value of x exists, and then the limit also exists. The value of y equal to limit at point 5 at x equal 5. So we can conclude that the function has no we can conclude here the function is continuous at point x equal 5. Okay, that's the first condition here. Okay, the second condition is you can refer page Okay, I would like to explain this example. Okay, in this example, we have this structural equation here. Fx equal to 16 divided by x squared if x equal or greater than 2, greater than or equal to. The second one is fx equal to 3x squared if x less than 2. We want to check at point x equal to whether the graph is the graph is uh the graph is continuous or not continuous when x equal to. Since we have this concept, no need to draw the graph. We just find the whether remember when we want to check whether when we want to determine whether the function is continuous or not. First, you need to check whether the value of the function exists at that point. The value of y, the value the value of y is defined, the limit is exist, and the value of y equal to the value of limit. When we're talking about limit, we refer to the right hand side and right hand limit and left hand limit. Okay, that's the first that is how to determine the limit. So we I hope you can remember this. You need to follow this three conditions. Okay, for this equation, okay, base we are going we, the question is about find the limit, determine whether the function is continuous or not at the given point. For this function number 3, at x equal to. So first we need to find what is okay, I will show you again. Okay, please refer to page question number 3, page 3. Page 3. Okay, let's see. Okay, let's see. I have this function. Function should say that fx equals 16 over x squared if x equal or greater than 2. Greater or equal to. The second part of the function is linear, 3x minus 1 if x less than 2. We need to check whether the function is discontinuous or not continuous at this point when x equal to. Okay, x equal to is the point where we must consider, we need to consider whether the function is continuous or not continuous. Okay. So first check whether fx is defined when x equal to. When x equal to, what is fx? What is y? What is range? What is output? When input x equal to. That how to that's about the question. You need to understand this question by using another word, another concept, another view. For you, I hope that can help you to understand what is the relationship between the limit and the value of y, the value of the function. For this case, we need to find the value of fx, the value of y when x equal to. When x equal to, okay, we've seen fx as two functions. There are two functions in fx. We need to decide which one should we use, whether 16 over 80 squared or 3x minus 1. 3x minus 1. So since x equal to, refer to this x equal or greater than 2. So when x equal to, the function follow the form follow this shape or this form, 16 over 8 squared. So this equal to 18 minus 16 squared when x equal to 16 divided by 2 squared. So 16 divided by 4, the answer is 4. Okay, now we know that. Now we can find the, we can conclude here, the value of y, the value of the function is defined. It can be calculated. Can be calculated. Okay, the rule number 2. Second condition here, we need to find the limit of fx when x approach sorry, the limit of fx when x approach 2, because number 2 is given in the question. We need to determine uh, the limit of fx when x approach 2. Okay, when x approach 2. So what is fx? Fx is okay. Before that, please remember this. When we find a limit, in this case, we need to find the left hand limit and the right hand limit. Okay, the first, the right hand limit, the limit of fx when x approach 2 from the right. So, based on the limit property, we can just simplify, just substitute x equal 2 into the, I think this is fx, into the fx, when x equal 2. And from the left, when x approach 2 from the left, what does it mean? We choose any value of x, the number is close to x, the number is close to 2, but the value is greater than 2. Maybe 0.01, 0.001, and so forth. So for this limit, okay, since we have two functions here, that you need to be careful here. Make sure you choose the right equation. So when we choose the value of x is less than, greater than 1, greater than 2, greater than 2, greater than 2. So we need to apply. We need to what we call it, the right hand limit is referred to when we want to find the right hand limit, we must use we must employ, or we must calculate the first part, because it is for area x greater than 2. Now we need to find the limit of the function when x equal to and more. When x approach 2 from the left, x approach 2 from the right, meaning that we choose any number that greater than 2 but close to 2. So the first function we need to apply here is the first part, 16 divided by x squared. 16 divided by x squared. Okay. So based on the property of limit, this is equal to 16 divided by 2 squared. 16 divided by 4, the answer is 4. So the right hand limit is exists. Okay, the right hand limit is exists. Now we need to find the left hand limit. The left hand limit. Okay, the left hand limit. The limit of fx when x approach to from the t. Sorry, when x approach to from the left. So in other words, we need to we have to find we have to choose any value of x. The value of x is less than 2 but close to. Less than 2 but close to. Okay, so when we choose x from the left, for the left, meaning that the value is less than 2, less than 2. So we need to apply this function, the second part of the equation, that is a 3x minus 1 if x greater than less than 2. So okay, the function that this argument show that we need to use the second function, that is 3x minus tx minus 1. Okay, this one. It's a 3x minus 1. This one, this 3x minus 1. So we just, based on the property of limit, we just replace the value. We just replace x equal to in the question. This is 3 times 2 minus 1. The answer is 5. So we can conclude here. Okay, there's a from the left, this one, yeah, there's the general form of limit. Okay, now we need to find the limit when x approach 2 from the left. Okay, the valid equation here is 3x minus 1. When x approach 3x minus 1 from the right. In other words, we choose any value of x, the number is less than 2 but close to. Okay, so in this case, based on limit property, we just replace x equal to in the question minus 1. The answer is 3 times 2, 6 minus 1 is 5. So now you can see here the right hand limit is 4. The right hand limit is 4. The left hand limit is 5. So in other words, we can conclude here the limit of 16 minus x squared when x approach infinity. Sorry, when x. Okay, now we want to conclude the continuity. The limit. So the limit for fx when x approach 2 from the right does not equal the limit of fx when x approach 2 from the left. The left hand limit is 5. The right hand limit is 4. So in this case, since the right hand limit does not equal the left hand limit, we can conclude that the limit of fx when x approach 2 does not exist. Does not exist. Okay, that's how to identify whether the function has limit or not. Okay, so the first part, the function is defined. Okay, the second part, the function does not have a limit. Does not exist. The limit does not exist when x approach 2. So in this case, since the function has no limit, the right hand limit does not equal to the left hand limit, we can conclude, no need to check the third regulation because the answer is the same. So we can conclude here, since the limit does not exist, does not exist, so the conclusion is the graph is not continuous. Fx is discontinuous at point x equal a. Fx is discontinuous. It is continuous. Discontinuous. Okay. Discontinuous. Continuous. And us at point x equal a. That the answer. When we find the continuity. Okay, any questions so far before I continue to the other example?
Betul?
Yes, silakan.
Um, yang the first equation that we need to calculate to find the y value, right?
All
The
right.
a.
Uh,
Why we need to use the 60 per
okay.
x?
Okay, good
Is that
question.
we can also use 3x minus 1?
Oh, okay. The question is, when we want to find whether the function is defined or not when x equal to, we choose 16 divided by x squared. Is that the question? Right.
Yes.
Yes. So why? Okay. Now we need to find. Okay. Again. Okay. I explain again. Okay. We need to find x at point x equal to, when x equal to, what is fx? Okay, since fx has two part here, there are two x this function has two form, two part. The first part is 16 divided by x squared. The second part is 3x minus 1. When we want to find f2, x equal to, what is y, what is fx, we need to choose whether we can, which one is a valid function. So we need look into the we call it, this is the condition, syarat dia ada syarat. 16 divided by x squared is valid if x is equal or greater than 2. So in this case, we choose x equal to. X equal to exists at this uh, function, at this part of the function. That's why when I choose x equal to, I must apply x 16 divided by x squared. For example, as comparison, let's say I choose x equals 0. X equals 0. So x equals 0, uh, which part, the valid function of this the valid form of fx when x equals 0 is this one, because this function say that for x less than 2, 0 is less than 2, so we need to choose this one. So f0 is equal to 3 times 0 minus 1, that is equal to -1. Is it okay? Is it clear? Is that clear?
Betul.
Okay, that in other words, please choose the right part of right equation in order to find the whether the function is can be is defined or not. But everything is subject to this condition. This condition. First, we need to determine what is x. We need to apply. We need to find we need what is the value of x. First, we need to determine what is the value of x. The next one is we need to what we call it, to choose the which part, which equation is valid for the function, by looking, by compare the value of x and this what we call it as this is the range, the range value of x, whether x, whether the number of x is less than 2 or greater than or equal to. Okay, that's uh how to determine whether the function is whether the function is uh whether the function is continuous or not continuous at a certain at point, at the given point of x. Okay. Okay. The next one, let's okay. Please refer to the note. Okay. This one. Let's say I have this function. I have this function. Find the point of discontinuity. Okay. This question asks you to find what is well at when in other words, this question asks you to find what is the value of x equal to what, and then at that point the function is discontinuity. We need to find the point of discontinuity. We need to find the value of x when the value of x where the function is discontinuity. Okay, it's quite difficult here because the value of x is not given in the question. You need to decide. You need to decide. Okay, I just share. There is a few tips here how to answer this question. For example, let's say okay, example number one. There is one the fx is continuous. Okay, I would like to choose this section B. Example B. Okay, because there are two discontinuous points here. Okay, let's say okay, I just write again this function. Okay, let's say uh let's say B. Okay, this one. Okay, given fx equal x plus 1 if x equal or greater than 1, fx equal to x squared minus 9 plus x plus 3 if x less than 1. Okay, so the question is find the point of discontinuity. The point of discontinuity. NUITY. Okay. You need to decide. This question asks you to decide where the graph is discontinuous. Is there any point? Is there any value of x that will result will cause the will is there any value of x when we put when at that value of x the graph is discontinuous, or or we can conclude later the graph is continuous at any point. There is no point of discontinuous. We need to select the point. We need to choose the point. Okay, how to find how to find the discontinuous point. What point we need to examine. Uh, uh, okay, the first one, which the first one is we need to examine the discontinuity at this we call it the border point. This graph changes the shape. The shape of the graph is changed, maybe from linear to quadratic, quadratic to exponent, and so on at this point. Before x equal 1, before x equal 1, this point, the form of the function is a rational function in a rational function. X squared minus 9 divided by x plus t. But after x, if x equal 1 and above, when x equal greater than 1, when x equal 1 and equal or greater than 1, the function change to the linear. Okay, this we call it this turning point. Okay, this turning point. Okay, so the first point is we need to check at the turning point x equal 1. X equal 1. Okay, that's the first tip. So if there is a rational function in the system, a rational function in fx, rational function is a ratio function. So the rational function, okay, there is a rational function here. The rational function, we call it rational. This fx has a rational function, rational part, the rational part. Okay, since fx has a rational part, we need to check the denominator. We need to check the denominator. So is there any value of x will result in the denominator equals 0? Okay. What is the denominator? Pembawah. X plus 3 equals 0. What is x? X equal to negative 3. X equal to negative 3. Since this equation has a rational part, so the denominator is x plus 3. When x equal negative 3, the denominator equals 0. Okay, that's the tip. You need to find what is the value of x. When we substitute this value into the equation, the answer is 0. Into the denominator, the answer is 0. So in this case, okay, the second point is x equal negative 3. What is the justification? Number one, why we choose number one? Number one is the turning point. Is the turning point. Now, negative 3 is the value of x will when we uh, x equal the negative 3, we choose x equal to negative 3 because when x equal to negative 3, the denominator of the rational function equals 0. That's the rule. There's two tips I can share with you how to determine the value of this continuity. Okay, now we need to check when x equal 1. Okay, check one by one for this equation. When x equal 1, is this function discontinuous or not at this point? X equal 1. X equal 1. So, what is the first step? Again, we just repeat the process. The first one, find f1. Is the function defined? Can we find the value of y when x equal 1? What is the function defined when x equal 1? When x equal 1, we must apply this. The function is at this point, the function is equal to the linear x plus 1. So when x equal 1, the value of y is 1 plus 1 equal 2. Now, now we know that the function is defined at point that the value of y is there. There is a black hole at that point when x equal 1, y equal 2. So this the first condition is passed. It's okay. At this point, the first condition is okay. Now we can proceed to the second condition. What is the second condition? We need to find the limit when x approach 1 for fx. We need to find the limit when x approach 1 from the when x approach 1 from the left. When x approach 1 for fx. Okay, in this case, we need to find the right hand limit and the left hand limit. The right hand limit when x approach 1 from the right. In other words, we choose any value of x. The value of x is close to 1, but greater than 1. In other words, the value of x is greater than 1. Again, we use x plus 1. What is x plus 1? So based on the property of limit, there is 1 plus 1. The answer is 2. So the right hand limit exists. The value of the limit is 2. The value of the limit is 2. Okay. How about the left hand limit? The limit of fx when x approach 1 for the left. When x approach 1 for the left, refer to the situation where we choose the value of x. The value of x is less than 1 but close to 1. When x is less than 1, so the valid function is x squared minus 9. The ratio x squared minus 9 divided by x plus 3 is equal to 1 to the power of 2 minus 9 divided by 1 plus 3. Okay, this is equal to 1 minus 9 is negative 8 divided by 4. The answer is negative 2. Okay, now the left hand limit is negative 2. So in this case, we can see here the right hand limit is 2, but the left hand limit is negative 2. So in other words, we can conclude here the limit, the right hand limit for fx does not equal to the left hand limit of fx. In other words, okay, since the right hand limit does not equal to the left hand limit, the limit does not exist. The limit does not exist. So the limit of fx when x approach 1 does not exist. Okay, so when the what is the implication when the limit does not exist? When the limit does not exist, the conclusion is we can conclude here that the function is discontinuous, not continuous at point x equal 1. So since the limit does not exist, we can conclude here fx is discontinuous at point x equal 1. So there is one point here where the limit there is a break in the graph. The graph jump when x equal 1, the graph jump at its turning point. Okay, the second one. Okay, the second one is at the x equal -3. Why? We have I have proved before. I proved before that when x equal -3, the denominator of the rational function is 0. So we need to check whether at this point the function is continuous or not continuous. So at the second one is x -3. The first step is find f -3. Check whether the function is defined, if the function can be defined, the value of y exists or not. Check sama ada fungsi tersebut mempunyai nilai ataupun tidak. So when x equal -3 is less than 1. So that is the value of y. The value of y is equal to x squared minus 9 divided by x plus 3. So this is equal to -3 to the power of 2 minus 9 x plus 3. X equal to -3. X equal to -3. So the answer is 9 minus 9 is 0. -3 plus 3 is 0. The answer is undefined. The value of y is undefined for this case. So again, this function is discontinuous at this point because the value of y is undefined. In other words, there is a break, there is a jump, there is a hole. Normally, we draw a circle, the white circle, white hole at this point, where to show that the value of y does not exist at this point. So now, if you can conclude, if fx is undefined at x equal -3, there is no need to check the limit. No need to check whether there is a limit or not. We can stop and we can conclude here. Fx is discontinuous. Discontinuous at point x equal -3. No need to check whether the limit exists or not. Since at the first step, if we conclude the function the function it cannot be defined at this point, we can conclude the function is also discontinuous. So in other words, there is no requirement, no need to proceed the process to find the limit. Okay, that's how to sometimes it's quite complex here. You need to identify the value. I just can share you this. There are two tips. How to determine which value of x we need to check whether the function is continuous or not. The first tip is check what is the turning point of the graph, and then the second one we need to find what is the value of x will if you what is the value of x when we change the value of x, we substitute the value of x in the question, in the rational question, the answer is 0. The equation of the denominator is okay. Okay, that's how to find the continuity for the graph. Okay, the last one, the last part for today, for this part, is the type of discontinuity. Basically, there are three types of discontinuity. This is just a concept. You need to know what is infinite discontinuity, the first one. The second one is a jump discontinuity. Uh, the last one is a removable discontinuity. All of these type is referred to the discontinuity. In other words, when we're talking about discontinuity, there are three types of discontinuity. The first one is infinite discontinuity. Okay, this function is said to have an infinite discontinuity at point A, at the starting point, when at least one of the one side limit is either infinity or negative infinity. Okay, this point is referred to the limit. One of the limit is a positive, is a negative infinity or negative infinity. In other words, the limit does not exist. The limit does not exist. Why the limit does not exist? Because the left hand limit, the right hand limit, or the left hand limit is infinity or negative infinity. For example, equation 1 over x has a infinite discontinuity at point x equals 0. For example, point x equals 0. Uh, okay, jump discontinuity is a condition where is a situation where one-sided limit exists, but the value are different. In other words, uh, the limit does not exist because the right hand limit does not equal the left hand limit. For example, uh, uh, at this point for this gx at point x equal 1. When we find the limit, the one the value of y is defined. Y exists at that point, but the right hand limit is 6 and the left hand limit is -4. So the limit does not exist. That's why we call it there is a jump discontinuity. The last one is a removable discontinuity. This refer to the situation where the limit exists, but uh, but either FA is different from the limit or FA does not exist. In other words, the limit exists, but the value of the limit is different from the uh, from the uh, uh, value of y. The value of limit it does not equal to the value of y. For example, in this case, let's say I have this function. Okay, at point x equal 1, the value of y does not exist, undefined. When the value of y undefined, we can conclude that there is the removable discontinuity. Of course, the limit exists. The limit exists. The right hand limit equal to the left hand limit, but the value of y is not defined at point x equal 1. So in this case, we can also conclude the function is discontinuous at x equal 1, but the type of discontinuity is removable discontinuity. Okay, this part is also very important. I hope you can remember this type of discontinuity. Again, in order to check whether the graph is continuous or not, we need to find whether whether the value of y is defined at that point x equal a, and whether the limit exists at point x equal a when x approach a, and the last one we need to check whether the value of y equal to the value of limit at point x equal a. Okay, I think that's all for this topic 5 and topic 5, limit and continuity. Okay, after this next week, for the next class, for the next lecture, I will continue to do. I will proceed to the topic 6, differentiation. Okay, any other question? Any question?
No, Professor.
Okay, if there is no question, I think that's all for today. Thank you for your attention. Okay, again for attendance, no need to scan any QR. You just I hope please wait until I end this meeting, and because I will I will download the attendance that I will download your attendance by referred by actually what I say is uh, your attendance actually is automatically recorded is automatically recorded by Microsoft team. I will download that file. The file will show your attendance. That's why it's very important for you to log in by using your UKMi. Okay, since there is if you have any question, you can ask me anytime. Okay, that's all for today. Thank you for your attention, and see you later in our next class.
Thank you, Doctor.
Thank you, Professor.
Okay, welcome.